subscribe and click the bell icon to turn on notifications.
In this tutorial, we're going to walk through authenticating to the Google Sheets API, creating spreadsheets and tabs, and reading, writing, and appending data to Google Sheets. Additionally, we'll take a look at adding conditional rules to spreadsheets with the API, as well as sending requests that can automatically format dates and sort ranges. We'll put all these concepts into a script that uses the API to automatically add, format, and sort data in a Google spreadsheet. There's a lot to learn, so let's begin. To start, let's open up a new browser. Then navigate to Google Sheets. You may need to sign into your Google Chrome or Google account in order to access Google Sheets. Now that we're in Google Sheets, click the green Sheets icon, and then in the templates, select Annual Business Budget. You may need to go to the template gallery in order to find the budget. It'll be by the Intuit QuickBooks team. Select the Annual Business Budget. This will create the file on your drive, and you'll be able to view the file and all the tabs inside the spreadsheet. The Setup tab shows the starting balance for our annual business tracker. The Income tab currently has a place for us to enter the different categories of income in the month that it occurred. The Expenses tab is very similar to the Income tab, except for it's a little bit longer and has a few more categories. The Summary tab is what you can expect. It's not recommended to edit this sheet. This sheet has graphs and also other pivot tables that display the summary data from the Income and Expenses tabs. This is the starting spreadsheet that we'll be using to access the Google Sheets API. Sometimes the most difficult thing about accessing the Google APIs is figuring out how you can authorize yourself to access the APIs and to provide the proper scope for the access that you need. The first thing that we need to do to get authorization to access the Google Sheets is to create a Google Cloud project. There is a Python quick start that the Google documentation provides that helps us do this. Open up a new tab and navigate to the Python quick start. Scroll down to step 1. Click the button Enable the Google Sheets API. This has a pop-up that allows us to name our cloud project. After we name our cloud project, we are then given credentials that we're going to use in our script to access the API. You can see that we're given a client ID and a client secret. You need to keep these secret so that other people do not have access to your API without your knowledge. On the screen you can read that we are now ready to start developing. Click Download Client Configuration. Once the client configuration is downloaded, you can hit Done, and we can close this tab. In the Python Quick Start, Google also provides us with a script that handles many of the problems that we have when connecting. This makes it easy for us to quickly connect and start programming and accessing the API. I'm sorry that I asked you to close the Python Quick Start tab, because now we're going to go back in and we're going to revisit that page to take a quick glance at the Python Quick Start script. Here's the Python Quick Start sample. It's not very long, but it can seem like there's a lot going on here. More importantly, for us, in the first steps, we need to download the modules that are used in the script. To do that, we're going to open up a command line application and make sure that we have these modules downloaded. Because I'm using Mac, I'm going to open up the terminal application. If you're on Windows, I'd recommend using PowerShell or downloading something similar to the Bash shell on Unix operating systems. That will make it easier for us to use similar commands when we're downloading these modules. You may have noticed that when I opened up a new terminal window, the base virtual environment was activated. I'm going to use Conda actually to deactivate that environment. I want to download these modules into a place where Python can access them globally. This isn't ideal for package management, but it is pretty reasonable for the scope of this video. Let's check to make sure that I have pip installed. Okay, I get a response that isn't an error. I also have the help instructions on using the pip3 commands. Back in the Python Quick Start, we actually have the code that downloads all the modules that we need. We can copy this code and then paste it on our command line. Whether you're on Mac or Windows, you may need to enter pip3 instead of pip to correctly install these modules. Perfect. I can see that the modules were installed correctly without error. And actually, I already had these modules installed, so many of the requirements were already satisfied. Next, we're going to open up idle and also open up an interactive shell with Python. We are going to first connect to the API and execute a lot of commands using the interactive shell. Python is great for learning in this way because we can execute commands one by one. This way, we are not using a script that runs through each command in a whole, and we can break down the commands to a more understandable size. That means that we're going to be copying and pasting a few of the commands from the script that Google provides us in the documentation until we get to a point where we can continuously use the Google Sheets API service. Now that we have a shell open, let's make sure that our Google sample script is within view so that we can grab these commands line by line. But before we start grabbing these commands, let's set up the project, making sure that we have a folder and the credentials within reach. Over in the Python shell, let's import the OS module. Then let's get the current working directory. We do this with the command git cwd. We're in the Documents folder, but I want us to be in the Desktop folder. I'm going to create a path that we are going to use to change directories into the Desktop folder. The best way to create paths when using Python is using the path.join method. I will not always use methods to create paths in this video. However, I want you to know this is the proper way for building paths, especially when you're using scripts. We can also use a helpful method called os.path.exists to make sure that the path that we just created exists. Okay, we know that we'll be able to navigate there. Let's change directories now. We're in the Desktop folder, and this is where we are going to create our project folder. We're going to call it Python Google Sheets. Once we make our directory, we should see the folder show up on our desktop. Earlier, we downloaded a credentials file from Google. This is in our Downloads folder. We want to move this file into our Python Google Sheets directory. That way we can more easily access it from our script and our project. We could open up the Finder or any sort of file management user interface or use the terminal to transfer it. However, we're using Python, so I'm going to use Python to move that file into our Google Sheets project. First, import shuttle. This stands for Shell Utility. Next, on the shuttle module, we can use the move method. Here I'm using tab completion to form a path. I know that the names of these files and folders exist, so when I start to type them in, I hit tab and they're found. In the Downloads folder, there is a credentials.json file, and I want to move that to the Python Google Sheets folder. We're going to use the os.path.join method to join the current working directory and the Python Google Sheets folder. Okay, it seems that credentials.json is not a directory, and that's true. It's a file, so I should not have included that last slash. I can use Control P to get the previous command that I executed. Then I can go back to that line, remove that slash, and hopefully move the file to the Python Google Sheets directory. Hooray, it worked. Let's open up Python Google Sheets to make sure that it's in there. Alright. Now we can change directories into the Python Google Sheets folder. I'm going to use a relative path to do this. The shell is now in our project folder. With relative paths, a period represents the directory that we are currently in. We can use the os.listDirectory method to demonstrate this concept. If I just enter a period surrounded by quotation marks and press enter, I get a list with credentials.json. This represents the names of all the files and folders in this directory in a list. If I were to change directories and use 2 dots, this would take me up one folder directory. I'm now back on my desktop. Let's change directories back into our project folder. Before we start executing commands from the example script, let's clear the console by exiting out of the shell and then opening a new shell. Next, we can start copying and pasting the import statements from the example script into the shell. We can execute them line by line to make sure that none of them throw an error. This might seem a little bit tedious, and it is, but this will allow us to interactively communicate with the API service. So far so good. We've imported all of the modules that we need. Next, we are going to modify the scopes variable that is a list with the scope that we want to access the spreadsheet with. There are many different scopes that you can access your Google Drive or spreadsheets with. This is the read-only scope. We need to change that because we are not only going to be reading values, we are also going to be writing values to our Google Sheets. Let's copy that variable, paste it into the shell, delete the read-only, and then the period. We can then initiate this variable. As a side note, scopes is capitalized because it is going to be unchanged in the script. It is a constant. In the example script, notice that there is a comment saying if modifying these scopes delete the file token.pickle. We do not have that file created yet, so we do not need to worry about deleting it. But if you were going to change the scopes again, and you had a token.pickle file in your directory, you would want to delete that first before you change the scopes. Next, we need to grab and define the spreadsheet ID for our Google spreadsheet. We're not going to name this variable sample spreadsheet ID. We're just going to call it spreadsheet ID. This is also not the ID for our spreadsheet. So let's delete that value, go back to our annual business budget tab. To find the ID for the spreadsheet, we need to look at the URL. The ID is the value between the d/ and the edit hashtag. This can be a little confusing or difficult to find. Let me highlight the ID in the URL. There is the ID for our spreadsheet. Let's copy that and then paste it as a string to initialize the spreadsheet ID variable. This is also a constant. The first thing that we're going to do with the API is to access a small range from the Setup tab. Let's go back to the annual business budget and look at the Setup tab. Here we have a starting balance of 5,000. Let's try to grab that value from this spreadsheet. To grab that range, we need to define that range as a variable in our interactive shell. Once again, let's copy the sample range name, delete the sample part of it, and then change the string value to reflect our tabs and our range. If you're unfamiliar with Excel, this is how you can access different tabs and different ranges depending on the spreadsheet. This video will not fully cover the syntax that is used in Google Sheets and Excel to access different cell values. We want to access the Setup tab, cells B11 to C11. We need to define one more variable before we start executing our flow control statements. That variable is creds, and that's going to equal the none object. The first code block that we see in the main function in the example script is right here. If the path exists for a token.pickle file, open the token.pickle file and read the value. That doesn't exist, so we're not going to execute that in our interactive shell at the moment, but we are going to use it in the script later. Now we do not have any credentials, so we want to execute this section of the script. If creds is none, or if the creds are not valid, then get a refresh token. If not, we're going to use the installed app flow module that we imported earlier. This is going to create a flow variable based on our credentials in the JSON file and the scopes that we defined. When we execute this block, a browser is going to open and have us sign in to our Google account. Then, after we successfully authenticate, it's going to save the token.pickle file to our current working directory, which is inside our Python Google Sheets project. If you copy and paste this over, you're going to have some indentation issues because this is indented in the main function. I have copied and pasted this into a text editor and unindented 4 spaces or 1 tab for this block, so I can just copy and paste it into the shell and then execute it. Okay, it looks like I'm actually not in my project directory anymore, so I am going to import OS and then change directories into that project folder. We're going to use 2 dots for a relative path, which takes us up 1 directory into my home path. The desktop folder is there, and inside the desktop folder, I have the Python Google Sheets folder. I'm going to close that string and change directories. Double check that I am in the right directory. Then I can use the Control P command again to get the command that I executed a few lines ago. Okay, so I executed that block and then a browser opened on a different screen to Google and wants me to sign in. I need to select my account. The next thing that happens is Google warns me that the app that I'm trying to access Google Spreadsheets with isn't verified, and this is a useful security warning. However, we know exactly what application we are using and how we're accessing the Google Sheets. Therefore, we can click on Advanced, and then we can click on Go to Quick Start or whatever the name of your script is. This will allow us to grant access to our desktop application. After I have granted access, I can then close this tab. Back in the shell, I get a little bit of output here, asking me to visit the URL so I can authorize this application. If we open up our project, we now have the token.pickle file, which means that we've successfully authenticated. We can now finally build the API service. Let's define the variable service and then call the build function, passing in the service type that we want to build, followed by the version for that service, and then finally our credentials, which we have saved in the creds variable. Next, let's create a sheet variable, and then on the service object, let's call spreadsheets, and then we're going to get a response object after we call the spreadsheets. To access the values, we need to call the values function, and then we're going to use a little bit of functional programming to string together a few calls, first using values and then using the get function. And the get function takes in the spreadsheet ID that we defined earlier, and then a range. The range we also defined earlier. This creates our request, and then we need to call the execute function to execute the request, which means that our request was probably successful. Viewing response objects can sometimes be messy. Let's import the prettyprint function on the prettyprint module so that we can see the response object with a little more clarity. Now let's use the prettyprint function to view our result. You can see that we used the major dimension rows to access the spreadsheet. The range that we accessed was the Setup tab, cells B11 to C11, and our values were starting balance and 5,000. So we successfully accessed that range and pulled those values from the spreadsheet. The response that we get is a dictionary, so we can continue to use the get function to access values in the dictionary. Now we have a two-dimensional list with the values that we just read from the spreadsheet. If you've gotten this far, congratulations. We've successfully authenticated and read values from our spreadsheet. Now that we know that we have the API service object created, we can start doing a more diverse range of things with our spreadsheet. To start, let's look at creating spreadsheets and creating new tabs in a spreadsheet. In the shell, to create a spreadsheet, we need to define the title properties for the spreadsheet. We're going to use a dictionary, first with a properties parameter, and the properties parameter is another dictionary object where we can define things like the title. There are many more properties we can define for the spreadsheet, but just for this example, we're going to define the title. Then we can build our object to call the API and get our response. on the service object, we're going to call the spreadsheets, and then we're going to use the create function to create a new spreadsheet. Here we are creating a spreadsheet, which is different than a sheet on an existing spreadsheet. This is going to create a brand new spreadsheet. And finally, we need to call execute to actually send the request and get the response. Then we can pre-print the response. You can see that the response is a very large object. This represents all the properties that we could have set or that we could have tweaked when we created the spreadsheet. There are many options for customization when creating a spreadsheet. Not only can we set the title, we can set the columns, the rows, the time zone, and the many values that affect the way the spreadsheet looks. Once we have created a spreadsheet, we can then call properties on it using the get method because the response is a dictionary. Here we can pull the spreadsheet ID off of the response object, and we can also pull the URL off of the response object. If we open up our Google Drive, we can see that we successfully created a spreadsheet called example. Here's the example spreadsheet that we just created. We just use this as an example. We're not actually going to use that spreadsheet, because now I'm going to show you how to create a new sheet on a spreadsheet, which I think is a little bit more common than creating a brand new spreadsheet. Creating a new sheet on a spreadsheet will be your first exposure to the batch update function. The batch update function is a very useful function with the Google Sheets API because we can group together many requests and send them all at once. To do this, let's define the request objects list. The request objects list is going to hold all of our request objects before they are sent. Let's create a new sheet request object. We need to define the action first that we're going to use in the batch update. Each action has its own set of properties and values that need to be defined for it to be successful. If we look in the documentation at the batch update function, we can find the request objects and all the different kinds of requests that we can send in the batch update. This is a good peek at all the different actions that we can perform on a spreadsheet using the API. Find and replace, we can duplicate spreadsheets, we can append to cells, we can sort the range, we can set basic filters. There are many different things that we can do with the API. If we find the add sheet action, we can see the kind of arguments and objects that it takes. It takes an add sheet request that has properties where we define the sheet properties. Here are the different properties that we can define for our new sheet. Let's go back into the interactive shell and define some of these properties. The first property we're going to define is the title property. We're going to call this new tab transactions. Then we can define some grid properties. If you accidentally select enter or get an invalid syntax error when you're filling out some of these longer properties, you can use the command Control P on a Mac to get the previous command back so we can figure out where we had gone wrong. We can define the amount of rows and columns that we want on the new tab with the grid properties. We can also define the tab color for the new sheet. This is defined in terms of red, green, and blue, but instead of a classic RGB value, we're going to use values between 1 and 0. If we decide to put 1 for red, this is going to mean that we are going to mostly want this color to be red. We want the green value to be represented at 0.3 of a full green. We now need to close all of the brackets that we opened previously in the object. Next, we need to add this object to our request objects list. We can do that using the append function in Python. Now we're going to create the body for our request, which is going to define a request property. Here we put our request objects list. Finally, we can call the API and get our response. On the service object, we're going to call Spreadsheets, and then the batch update function. On the batch update function, we need to use the spreadsheet ID, we need to pass in the body, and then we can execute the request. I forgot to define the properties property on the add sheet object. I'm going to jump back a few commands to when we defined the new sheet object. Under add sheet, I need to define a properties property, where then I can choose the title, the grid properties, and the tab color. That looks a little bit different because I didn't quite get the indentation right, but the syntax generally is correct. Since we're in interactive mode, we'll have to go back and redefine some of the variables that we had defined since, or accessed, since we started trying to create a new spreadsheet. The first of which was the request objects list. Then we need to reappend the value into the request objects. We can redefine the body, and then we can try to call the API again. Here we saw no error when we tried to call the API. If we go back to our spreadsheet, we have a new tab, or a new sheet, called Transactions, and we also added the tab color, which was a mixture of red, green, and blue. This is an empty tab with the amount of rows and columns that we defined in our request. Let's take a look at this response object with the pretty print function. In the request object, we have the replies property with a list of all the replies from our requests. We can look into this response by using the get function and some indexing into the lists. Get the replies property is going to get us the list that is at the front of our response object. The first index on that list is the response that we got for our one request. On that one response, we can use the get property to grab that add sheet response. Finally, we can pretty print this small object. Our new tab has the properties defined in this object. These will return to us once we successfully created the new tab. Later in this video, we're going to use the Transactions tab to demonstrate how you can write values to a spreadsheet, append values, add conditional formatting, and also sort ranges using the API. Now that we have a fresh sheet on our new spreadsheet named Transactions, let's write values to that sheet using the API. First, let's define some example values using a list comprehension. A list comprehension is beyond the scope of this video. At a basic level, a list comprehension can let us quickly create lists. Let's define the data that we're going to add to the spreadsheet. This is a list comprehension. This is going to create a list with the values 1 to 10. We're going to add these values to our Transactions tab. Let's create a values list, which is a two-dimensional list that has the row values that we want to add to our spreadsheet. Let's take a look at the values. In the body of this request, we are going to define a values property and give it the values variable that we just defined. Then we can pass this body into our request object. This request is going to return values that we added. So we're going to use the values function on the spreadsheets function to get those values in our response. To add a single range, we can use the update function. This is going to update that range in the spreadsheet. We need to provide the spreadsheet ID, the range that we want to update. On the Transactions tab, let's update starting at cell A1. We then need to choose a value input option. There are a few different value input options, including raw and user entered. You'll typically find yourself using the user entered value for the value input option. This is a way to enter the values into the spreadsheet as if somebody was actually typing in the values into the spreadsheet. Finally, we need to add the body onto the request, and then we need to execute the request. If we define the response object before calling the execute function, that's fine. We can just use the execute function on the response object that we just defined. You may have noticed that the spreadsheet updated when we executed that request. We now have the values 1 through 10 starting at cell A1 and going down the first row. To update multiple ranges in a spreadsheet, we're going to use the batch update method. Let's go into our spreadsheet. Let's select the values that we just added and delete those. Back in the interactive shell, let's define some column data, and then we'll use the row data that we had from the previous example. Define the variable column with the values A, B, C, and D. Then create a data variable, which is a list. This list is going to hold the range objects that hold our updates. Let's define the object row data, open up curly braces. The first property we need to define is the range that this row is going to update. This range is going to be on the Transactions tab, and it's going to start at cell B1. We can be more precise with our A1 notation. We could do B1 through F11 or F2 and define longer ranges. However, it may be easier just to define the cell that you want the values to start at, and they will fill themselves in accordingly. After we define the range, we need to provide the values for that range. The values has to be a two-dimensional list. So we can open the list, add our row list, and then close it. Let's close that dictionary for the row data, initialize the variable, and then define the column data. The column data also takes in a range property. For this one, we're going to start the transactions at cell A1. The difference between the row data and column data is how we can define the major dimension. The default major dimension is row data. But if we want to define values in a column, we need to give the major dimension property the value columns. And then again, just like the row data, we need to provide the values. Let's append both of these values onto the data list. Now we can define our body object for the request. The body object takes in the value input option for the values that we want to add. This is going to be user entered. And it also takes in the data object defined on the data property. Let's close that object, and now we can send our request with the batch update function. You might be able to start to see a pattern where we define the values and some of the other objects that are specific to the action we want to take. We then add those objects to a body or a data property, and then send that body with a request on the service object. This is the general workflow for adding values or performing actions on our spreadsheets with our spreadsheet service object. For the batch update, we need to add the spreadsheet ID, followed by the body, and then we need to execute the request to get the response. Again, our spreadsheet updated, and we have our column data starting in cell A1, and then our row data starting in cell B2. Let's pretty print our response from this action. On the response object, we're going to grab the responses property. In this response property, we have a list with both of the ranges that we updated. These show the updated cells, the updated columns, the updated range, and also the total updated rows. Furthermore, we also get the spreadsheet ID returned in this property on the response object. Earlier in this video, I briefly showed you how to read a single range from a spreadsheet. Let's quickly review reading a single range from a spreadsheet. We can jump straight to the response object if we're just going to read a single range. We'll call the spreadsheet functions, get the values, and then use the get method, first defining the spreadsheet ID, then defining the range that we want to retrieve, and finally executing that request. Again, let's use the pretty print function and then the get method to retrieve the values off of the response. Here we have a two-dimensional array. The first value in the array is the first row. The second value is a list of the second row. The third a list of the third row, and the fourth a list of the fourth row. This is what happens when you retrieve a grid using the get method. We could then possibly iterate over these lists to get them one by one. Next, let's take a look at reading multiple values from a spreadsheet. Instead of using the normal get function, we are going to use the batch get function. Let's define a variable called range names. This is going to be a list with the ranges that we want to retrieve. Then define the response variable again. Everything is going to look pretty similar, except for we're going to use the batch get function. The batch get function takes the spreadsheet ID, and instead of range, it takes ranges as one of its parameters. And the ranges is the range names list that we just defined. Let's close the parentheses and call execute. And for this one, we're just going to iterate over these values to print them. Instead of values, the property that we want to pull off of this response is the value ranges property. And then let's pretty print each row. So each of these value ranges has the major dimension that we grabbed, the range, and then the values. Although we grabbed ranges A1 through A4, we grabbed them as rows, so each of those values is a list. If we wanted to grab them as a column, we'd have to specify the major dimension. Before we get into building our project script, I'm going to show you how to do one more thing with a spreadsheet, and that is how to append values onto a spreadsheet. Appending values will add the values to the bottom of a specified spreadsheet. It'll also add rows if there aren't enough rows on the spreadsheet. To append values to a spreadsheet, we need to define the values first. For our values, I'm just going to repeat the row variable that we defined previously. Then we define a body object, passing in values for the values property. And then we can send the request. The function that we use to append values is named append. Let's add the spreadsheet ID. The range that we want to append the values to. The body that holds the values. And finally, the value input option. Keep an eye on the spreadsheet. Okay, so I was a little bit confused when the 3Ds got added to the bottom of the A column. So I decided to run it again to see if I could get different behavior with a different range. However, I then realized that the values variable was actually holding 3 rows with the letter D. So when I went to append those rows, it actually appended the proper values. I had just defined some strange values with the row variable. Let's go into the spreadsheet, return it to what it was when we first started, and then make sure that we define the proper values for the row variable. So right now row equals the letter D. Let's have row equal a list with values 1 through 10. Then we can redefine the values variable with each row. Redefine the body object with the values variable with the correct values. And then we can jump back and send the request with the first range that we defined, transactions, column A. We got the expected behavior where we added the 3 rows that had the values 1 through 10, and it appended those values at the bottom of the A column, or after the last value that was in the A column. Later in the video, we're going to add many rows to this column so that the rows exceed the amount of columns that are currently in the spreadsheet, so you can see that it will keep appending rows onto the spreadsheet even if those rows are not currently available. We are now ready to start moving into the part of the video where we build our script. This will involve us creating example transactions that we can add to the spreadsheet, and also adding some Excel formulas to the spreadsheet so that the cells automatically add up our values that we put in the Transactions tab. We'll be looking at some of the batch update methods, as well as adding conditional formatting, sorting ranges automatically, and adding a chart. But to start out, let's select all the values in the Transactions tab and delete those. Next, we're going to build some example transactions from scratch so that we all have the same data that we'll be adding to the transactions sheet. I might go a little bit quick through some of these sections for creating these transactions, but some of the actions are a little beyond the scope of this video, so I hope that you'll be able to follow along as we create these transactions. The first thing that we're going to do is we're going to grab the category ranges from the income and expenses sheet. We want to grab the categories from the income and expenses because we want these to be in our example transactions. And we want the categories to line up between the example transactions and our spreadsheet so our formula can parse the transactions more easily. To do this, we're going to grab multiple ranges from the spreadsheet, one range from the income tab and one range from the expenses tab. We'll start by defining those ranges in a list, the first one being on the expenses page in the E column, and the second one being on the income page in the E column as well. Then we can execute a API call where we use the multiple ranges to pull the values from the spreadsheet. We'll use the batch get. We'll pass in the spreadsheet ID. The major dimension that we want to grab is the columns. And finally, the ranges that we defined in the previous command. I'm going to repeat that command and make sure that I'm using service and not services. And we get our values. Let's see what these values look like when we retrieved them. Okay, so we have two-dimensional lists, the first one being the expenses and the second one being the income categories. Let's put the value ranges into a variable called val ranges. We can get those ranges by using the response.get. And we're going to create a category dictionary that will have a parameter for the income categories and a parameter for the expenses categories. Let's define that variable. Using curly braces for a dictionary, the first thing we're going to do is iterate through the value ranges. If you notice, each list starts with either income or expenses, depending on which categories they apply to. We can loop through these two lists, pull out that value, and then assign that as the dictionary value for each of the category lists. So first, we'll set up a loop through the value ranges. Then we'll check to make sure that the values are actually there. We'll then define a variable in the local scope, in the local function scope, called cat list, and we'll pull the values off of that list and then index into the first value. Next, we'll assign the keys to the dictionary based on the first value in each list, which will either be income or expenses. we'll assign the value to that key, all of the values in the list except for the first one. We do that by indexing into the category list. Let's check the dictionary keys to make sure that we have income and expenses keys. Let's take a look at the values in one of these dictionary keys. There are two things we want to take out of these category names. One is the empty values, which were pulled because there were empty rows in the column. Also, monthly totals is repeated in the list a few times. We want to create a function that'll pull out those values and then remove them so that we just have the category names and there are no duplicates. To do this, we are going to iterate over each of the key value pairs in the dictionary. Then we're going to use a lambda function to filter out the values that are either empty strings or that equal monthly totals with a full colon. We're going to grab the keys and values from the category dictionary.items, and then we're going to use each key to grab the values from the category dictionary. We're going to need to use the list constructor to convert this value back into a list. I spelled lambda wrong. The list that we're passing in to the filter function is going to be the category dictionary for each of the values, whether that's income or expenses. And then finally, let's use a print format to then print the new category list for each of the values in the dictionary. It looks like we were close, but I put an X here instead of a K. Let's rerun this. And I did not add the other brackets to my print format, so the full categories were not printed. Although this is not super important to this command, we're going to get it right anyway. Now we can see each of the category names for the expenses and the income. We have removed the blank strings and also the monthly totals that was repeated in each of the category lists. We now have categories that we can sample from for our income and expenses transactions. Now we need to create amounts that we can sample from to randomly choose to add with our income and expense transactions. To generate these amounts, we're going to import random, then we are going to create some sample transaction values using another list comprehension. The sample transaction values is going to take an integer between 1 and 99. It's then going to add a random value between 0 and 1 to represent the cents that may be in between transactions. it's going to round that value to 2. So in the end, we're going to get some values that look like this. We can sample from these values to represent a variety of different amounts that come in on transactions. We can now make 2 types of transaction values: income transactions and expense transactions. We're going to use the random choice function on the random module to sample from the sample transaction values. And we're going to grab 100 positive integers from the sample transaction values. Those are going to represent our income transaction values. Our expenses transaction values will use the same list comprehension, but we're going to add a minus sign at the start. This will make every transaction that we grab a negative number. We can now combine these into a larger example amount values. We now have the income and expense categories and the income and expense transactions. Finally, we need to get some dates to represent the different dates that these transactions occurred. To do this, we're going to import the date module from datetime. We can use a few built-in functions and the random.choice function to generate random dates. We can pick the year, the month, and then use the random choice function to pick from a range of different values between 1 and 31. This represents different days in September between the 1st of the month and the 31st of the month. We can then convert this to an ISO format to make it a little bit easier to read. Let's run that function a couple more times to demonstrate this randomness. We have 3 different values in September. This will be a fairly long for loop where we'll grab example categories and amounts for whether this is an income transaction or an expense transaction. Then, for both of these transaction types, we're going to add a random date in September. Let's define the example transactions list where we will append our example transactions. We're going to generate 100 example transactions. First, we'll grab an amount from our example amount values. If the amount is greater than 0, it means that we have an income transaction. We're going to append a list to the example transactions list, the first value of which is going to be a random date. We're going to grab a date from the year 2020, the month September, and then we're going to randomly select the day. It looks like I did one too many random choices. We're going to use random choice to select a date from a list of date options between 1 and 31, representing the names, and then we're going to convert that to the ISO format. The second value for each transaction is going to be the amount value, And the third is going to be a random choice from the values in the category dictionary that is an income category. If the amount is not greater than 0, then it means that it's going to be an expense. We're going to do the same thing, but we're going to change the values to reflect the values that would be expenses. We can copy the example transactions because we're going to append the same date values and the amount, but instead of income, we're going to grab from the expenses categories. Finally, we can pretty print the example transactions. We actually need to execute the value first, and then we can pretty print the example transactions. I'm slightly embarrassed to admit that September only has 30 days and not 31 days. So when we run this function, we need to make sure that our range is between 1 and 31. This will grab values between 1 and 30. We need to make sure that we do this for both times that we're accessing the date. And we should have our example transactions. We have 100 example transactions that we're going to add to our annual business budget. The way that we get this two-dimensional list representing our transactions into our script or our shell isn't exactly important. It's just important that we have a two-dimensional list that has our row values. I'm going to add these transaction values to a CSV file. So our script will be pulling from a CSV file and then adding it to our spreadsheet in Google Sheets. However, there are many different ways that you can grab information or values and add them to your Google Sheets. You just need to be able to convert those values from whatever file format they are coming from into a two-dimensional list. So very quickly, we can import CSV. And then we can open up an example transactions CSV file. We can then create a CSV writer object by calling the writer function on the CSV module. We're then going to represent a CSV file that was pulled from some sort of software by adding names to each of the columns. And then finally, we're going to write our example transactions to the CSV file. We get a little bit of output. Let's list the files in this directory. And we now have the example transaction CSV in our project folder. Before the spreadsheet can find and add up all of the transactions in the Transactions tab, we need to add formulas across all of the cells that represent areas where we would add values. This is going to be a little bit tedious, but we're only going to do it once. We are going to take this formula and enter it in cell F3. I can't break down what this formula does step by step, but it'll add the right transactions into the proper spot if we get them on the Transactions tab. We can take this formula and then pull it across each of the rows. I'm going to speed up the video as I do this, but we'll have to update one of the values when we jump down to the other category. Down in interest earned, we need to change the formula to reflect the category that is in that row. This is going to be cell E11. So instead of E3, this needs to be E11. We'll have to do this for the expenses page as well. Okay, let's go to the expenses page, and let's enter this formula at the top of each of these categories. Coming up in the video, I'm about to make a small mistake that then I repeat over all of the cells in the expenses tab. Instead of the value in this SUMIFS function, instead of it being numbers that are greater than 0, I need to make it numbers that are less than 0. That's the only way that the expenses tab is going to be able to determine whether a value is an expense or income. On the income tab, the formula needs to look for amounts that are greater than 0. I'll correct this later in the video, but to save yourself the trouble, I would change this value to less than 0 instead of greater than 0 before you start pasting and pulling all the values across the cells. I am going to go through and extend this formula to each of the cells and rows in this spreadsheet. However, if you don't want to do that, you can just pull this first cell across and then just focus on the September column, because that's the column that we'll be adding transactions for. So you need to copy this value, add it to that row, change the E value to reflect the category. So this will become E9. And then pull that down for each of the categories. Again, we need to enter the formula. This is E17, so we'll change this to E17. And then click and hold the bottom right to pull that down to the end of the category. I'm going to do this for every category, but like I said, you could only do this for September because that's the only month we'll be adding transactions for in this tutorial. Okay, we now have all of our formulas entered into the rows and columns, so we can successfully grab the values from the Transactions tab and use them in the Income and Expenses tabs. We can shrink this window back down and then jump back into the shell. Let's read the values from the example transactions CSV. We're going to create a reader object with the CSV module. We're going to pass in our file, and then for each row in the reader object, we're going to print the row. We can iterate over each of the rows in the spreadsheet in this way, and then we can add them to a different list that can be appended to the transactions sheet. Let's create the transactions list that we'll be appending the values to. We can then go into our history and convert this statement to just append the row to the transactions list. Let's check the length of our transactions list to make sure that our transactions were added. We have 149 transactions in our transactions list. You may have a slightly different amount in your transactions list. I have a few more because I had the error that occurred twice based on the date. Now, when the date was not fit for September, the transactions were still being added in that time. So my example transactions had a few more transactions when I ran it the third time. Recall that the first row in the CSV file is a column header. So when we build the body of our request, we're going to ignore the first value in this list. Let's define the body for the request and then pass in our values. For our transactions, we're going to ignore the first value in the transactions list and then initiate our body variable. We can then do what we have already learned and append these values to the transactions sheet. We use the append function. We provide the spreadsheet ID. The range that we want to append to is the Transactions tab in the A column. We pass in the body, and then finally we need to define the value input option, which is going to be user entered. We can then execute this request. We did not get an error, and let's take a look at our Transactions tab. We have all of our values that were appended to the Transactions tab, and the rows were extended to fit all of our transactions. If you scroll over to September, we notice that we do not have any transactions showing up, nor do we have any transactions in the income spreadsheet either. The issue here is that the values for each of the months at the top of the spreadsheet are based on 2016. So we need to update this to 2020 for it to work. Let's go to September and let's change this to September 2020. And then go to October and change this to October 1st, 2020. And then you see our September values do appear. If you were adding transactions for different months, you would want to go back and change all of these to reflect the proper year. I realize that the formula that we used to enter the expenses and to find the expenses is actually looking for positive values, and this needs to be a negative value. So now we're going to pick up on the negative values that are the expenses from the Transactions tab. So to change this for all the values, we can just pull this down, and then for each of the different categories, change this value. Instead of greater than 0, we want it to be less than 0. Okay, so not only do we have transactions showing up or totals showing up for our expenses and income sheet, but our summary sheet is also linked to these. So we have summary values in our summary tab. Now that we know that we're able to successfully add transactions to the Transactions tab and then tally those in the income, expenses, and summary spreadsheets, let's build our script that can do this as needed. To start making our script, select idle, and we should have a blank file available for us when we first launched idle. If not, we can select new file from the navigation bar. Let's save this file as main.py inside of our project directory. This will be inside of the desktop and then Python Google Sheets. In this file, we're going to need to do many of the things that we did at the beginning of the video, which was import the proper modules, check for credentials, get credentials if we don't have them already, and then build an API service. I'll be copying and pasting in these values for the script, but you should be able to do the same based on the commands that you executed previously in the video or from the Google Python Quick Start. First, we need to import the modules. Then we need to define the scope. After that, we need to define our spreadsheet ID. I do not have this value available, so I'm going to grab it from the URL. Now we need to grab both of the if blocks that were in the Python Quick Start that check to see if we have credentials. After that, we can build our service. After we build our service, we need to initiate a transactions array that we can add our transactions to. This script assumes that there's a CSV named example transactions in the current working directory. This file can be switched out depending on whatever transactions that you may want to be adding. However, it needs to be called example transactions. Then, just like in the interactive shell, we need to create the body, and then we can execute the request and response. Let's save this file and try to run it. If it's successful, we should have just short of 300 values in our transactions tab. I'm missing a parentheses. Let's save this one more time and then try to run it. Over in the shell, I ran the file and I got 0 output. Now I would expect no output if this were successful. Let's look at our transactions. We now have above 149, and it looks like we have just short of 300 transactions. This is reflected in the income and the expenses. If we were to create some example transactions and change the month, we could add a lot more example data into the spreadsheet. However, this current script takes values from a CSV file in the same folder and then programmatically adds as many transactions are in the CSV file to the Transactions tab. The next thing we're going to do is we may want to have these transactions sorted in case we had questions about what certain transactions were causing what amounts. We're going to format the dates, sort the spreadsheet by the dates, and then highlight the expenses that are over $100. The Google Scripts API defines many different ways you can format dates when you add them to a spreadsheet. Here you can look at some of the date and time format examples. You can also view the format patterns and take a closer look at some of the number format tokens. We're going to grab one of these date and time format examples and change our spreadsheet to match that pattern. To update dates to a certain format in the Google Sheets API, we need to use the batch update function and pass it a repeat cell request. Recall that in the Sheets API, we have many different actions that we can take with the batch update function. Let's go back to the interactive shell and we'll add this format to the dates in our spreadsheet. We are still connected to the API with our service. To change the date formats, we'll need to get the ID for the transactions sheet. This is what we'll have to do when we define grid ranges in our request. To get the ID, let's define a variable sheets and call the service object using the spreadsheets function. And then we'll call the values function on the spreadsheets. Let's pretty print the sheets variable that we just defined. Looks like we lost the pretty print module, so let's import it again. And then pretty print the sheets. We have a discovery.resource object. Let's redefine the sheets value again, but let's remove the values function call. Now let's pretty print this variable sheets, and we see that we get a lot of values for the spreadsheet. Eventually, down towards the bottom, it's going to print the properties for the transactions spreadsheet. We have the sheet ID here at the bottom for the transactions tab. So we're going to copy this value and then define a sheet ID variable in the shell. Here at the bottom of the shell, define the variable sheet ID. We're going to capitalize that. And then paste in the number for their sheet ID. Now we can define a request object and use the batch update function to format the dates in the transactions tab. Let's start by defining the requests variable, which is going to be a list with a single object. The action is going to be repeat cell. And we need to define a grid range. The reason we needed the sheet ID was because it is a required parameter when defining a grid range. The start row index for the grid range is going to be 0, which is the first row. The start column index for the range is also going to be 0 because we want to get the full sheet. And the end column index is going to be 1 because we only want to do column A. So index 0 to 1 represents column A in the spreadsheet. Next, we need to define a cell property. This has a user entered format. And this takes an object where we can describe a number format. The type for this number format is going to be a date. And the pattern we can grab from the browser tab that we were on earlier. Let's go back to the date, numbers, and formatting, and let's find the example dates. And then we can just copy and paste this example date into the shell. After we add the date pattern, we can close a few of the objects. And then we need to add one more property to the repeat cell object. This is going to be the fields. And in the fields, we are going to enter user entered format and then select number format. We need to close one more object and then close the list. That defines our request list that has our repeat cell request. Now we can define a body, passing in a parameter requests, and then we're ready to call the API. We're going to use the batch update function, add the spreadsheet ID, then the body, and then we're ready to execute this API call. This should change all of the current dates to reflect the pattern that we entered in the cell object. Let's open up our annual business budget, and you can see that we now have a different format for all of the dates. This will be helpful, and we can use it in our script, because when we add the transactions from the CSV file, it may not automatically pick up on the date format. So we can execute this every time we add transactions to make sure all the dates are the same. Let's go back to our script, and let's add this API call to the bottom of our script. First, let's take the sheet ID variable and define that. Then we can copy the request object, quickly define the body, and then at the end we can call the API again. Let's save the script and then we'll test that to see if we can add transactions and reformat the dates once they're added. Now that it's saved, we can click Run and Run Module, and we don't get an error. We now have many more transactions added and they all have the date formatted to the pattern that we provided. Next, let's take a look at the sort range option so that we can sort all the transactions from September by ascending or descending order based on the date. We can jump back to our request browser, search for the sort range request. We can see that it takes a sort range request object. The sort range request object takes in a range and then sort specs. The sort specs look at the order, it can look at the color, dimension, background style. Let's take a look at the sort order to see what we're working with. This determines the ascending or descending value of the sort order. So we can define a range and then choose the sort order to sort the values whether they are ascending or descending. This works with dates as well. Let's go back into our shell and we'll first define a sort range. The sort range is also a grid range, so we're going to need the sheet ID. We can then define a request list where we'll add a request object that has the sort range action. We'll define a range and pass in our sort range variable. And then let's add the sort specs. We can add multiple sort specs, but the only one that we're going to add to the sort specs list is an object with the property sort order, and we'll give it a value of descending. We'll close that object, close the sort specs array, and then we need to close two more objects and the requests array. Nothing new here. We're going to define a body object, add the parameter for requests, close the body object, and then we're ready to send the request with the batch update. Let's go back to our spreadsheet and check to see if we sorted the ranges. Yes, it looks like all of the dates are now sorted in descending order based on the date. This could be another aspect of the script that we add so that when transactions are added per month, the dates are sorted in descending order from the most recent to the oldest. Now what's different about this in the interactive shell than in the script is that we don't need to define another request object. We can simply add another object to our request list. So instead of defining this whole object and then the body, we can just take the sort range object and we can add that to the request array. This is one of the useful aspects about the batch update method, is we can send multiple updates at once. Let's save the script and then we'll run that again. and we should expect to have dates sorted and formatted. Looks like I forgot to add the sort range variable. And we need to add that below the sheet ID. Let's save it and run it again. And it looks like we were successful. You may have seen the spreadsheet update in the background, and all of our 740 transactions are formatted and sorted. The last request that we're going to add is a conditional formatting rule to the spreadsheet. The conditional formatting request takes in a grid range. So let's define the grid range as my range. We'll pass in the sheet ID. The start column index is going to be 1, which maps onto the start of the second column in the Transactions tab. The end column index is going to be 2, which means that we just want that second column, which will be the numbers. And we're going to start at the first row, which is represented with a 0. We can close my range, and then we can form our requests array. The action is called Add Conditional Format Rule. First, we need to define the rule object. The ranges for the rule consists of the range object, my range, but we need to put it inside of a list. So make sure that you add the brackets to put that range object inside of an array. Then we can add a Boolean rule. We need to define properties on that Boolean rule. We're going to look at the number greater than or equal to action. And for the values, we're going to open up another array and define user entered value again. And this is the value that we want the decision to be based off of. So this is based off of the user entered value of 100. Close the object and close the array. This applies to values that are greater than or equal to 100. And since we actually want to highlight numbers that are less than or equal to $100 for the expenses, we are going to change this to a number less than or equal to -100. The type of Boolean rule that we can add can be found on the documentation page. The documentation page has a whole list of different values that we can add based on the values in the cell. This can involve dates, it can involve text, numbers, it can also involve other Boolean values that you have entered into the cell. After we define the Boolean rule, we're going to close the Boolean rule, add a comma, and then define the format. This is going to involve a text format. We want to change the foreground color, which is the color of the text, to red. Then we need to close these objects and then add an index of 0. Then we can close the array, and that defines our requests array. A little bit more properties. Then once again we can define the body. We can then call the API using the batch update function. We got an error, and after I inspected the object, it looks like I forgot to add a condition property above the type, values, and text format. So inside of the Boolean rule, we need to add the condition, and then we'll add another object. That slightly changes the look of our object, but I added the brackets in the correct place, so now this should work. Let's redefine the body parameter, and then we'll send the request again. The requests seem to have executed correctly, but we don't see any changes on our spreadsheet. And I realized the reason we don't see any changes on our spreadsheet is because when we selected our sample amount transactions, the maximum value was actually 100. So we should change that user entered value to -50 to actually see some of the conditional formats. To check that the conditional format was actually added, we can view the conditional formatting rules in the spreadsheet. You can see that our rule was added for a value is less than or equal to -100, and we want it to be red, and we're applying it to the proper column. So everything that we did was correct, except for we chose a value that was outside of the transaction range. So let's delete that rule, and then we'll redefine the request variable, and then redefine the body variable and send the request again. Let's change this to -50. And as soon as we did that, we saw a lot of these numbers light up with red highlighting. So now we formatted the dates, and we've also conditionally highlighted the expenses that were over -$50. Because this is a conditional formatting rule, we only want to add it once, or we may continuously add it more times than we would like to. That means we don't need to include this into our script, because once it's added, it's there. So now any new transactions that we add will comply with that conditional formatting rule. Let's take another look at our script. We can close out of the shell since we're done executing commands. Let's next go through our application, and we'll put some comments in to help break down what the script is doing at each point. At the top of the file, we are importing the modules that we need. A little bit further down, we are defining the constants that we will need for the authorization of our script. After that, we are authorizing the script. Just above the service declaration, let's leave a comment that says we are going to build the service in this area of the script. After that, we want to load the transactions or data of any sort. We want to declare our first request body. And then we want to send our transactions or send our data API request. After that, we're going to send an auxiliary API request, and we're going to define a few variables to help with that API request. We're going to modify the sort range variable, and we're going to capitalize it. Which means we also need to change where we use it further down in the script and make sure that we are capitalizing it here as well. Here we're going to build the multi-request array for our secondary API call. And then we're going to redefine the body variable for our second API call. And finally, we send our secondary API call. That does it for building our script. In this script, we've set up a nice template for authorizing the script to access the Google Sheets, sending a API request that appends data to a spreadsheet, and then sending other request objects to further modify and format the spreadsheet with the API. There are plenty more actions that can be added to the request array to modify the API. You just need to use the documentation and follow some of the same steps that we followed in the preceding video lectures to understand how to add those to the requests array. Let's run the script one more time, but first let's delete all of the transactions that we currently have in the Transactions tab. Let's check to make sure that our expenses are clear and our income. We should not be reading anything for September for those months. And the summary is blank as well. We are in the Transactions tab, and let's run this script. And there you see that the transactions have been added, formatted, and sorted, and the conditional formatting rule has also taken effect for the expenses that were greater than $50. That does it for our script on accessing the Google Sheets API.
If you're not a subscriber, click down below to subscribe so you get notified about similar videos we upload. To get 4 free courses in Excel, QuickBooks, Microsoft Project, and Photoshop, click over there. And click over there to see more videos from Simon Says It.